This is Babitha, working as Assistant Professor in the Department of ECE in Institute of Aeronautical Engineering. In this session, I am going to discuss the question bank solutions for the Mosfet circuits that belongs to the module 2. So, in the Mosfet circuits, we are having the syllabus. We are going to discuss about different Mosfet circuits and the different types of Mosfet circuits, the depletion type and enhancement type Mosfet circuits. And in the depletion and enhancement type, we are going to discuss N-channel and P-channel types. And in all the four cases, we will discuss the current voltage characteristics and how the MOSFET acts like a switch and small signal equivalent circuits of the MOSFET. And from the small signal equivalent circuits, we are going to calculate the input-output impedances and gain. And the small signal model for all the common source, common gate and common drain amplifiers, and the transconductance of each and every amplifier, and high frequency equivalent circuit of the MOSFET we're going to discuss in this module. So the questions related to these concepts we are going to discuss now. So in this question bank, we are having three types of questions, that is part A, problem solving and critical thinking questions, and part B belongs to the long answer questions, and part C belongs to the short answer questions. So in the first, we are moving for the problem solving and critical thinking questions. So in that first question is the define three FET parameters GM, RD and mu here. That is transconductance, drain resistance and amplification factor of the FET, and we have to prove the relation equal to GM into RD. So here transconductance is nothing but the ratio of the change in drain current to the change in gate voltage. Okay, and this one we can calculate from the drain current versus gate voltage curve here. And drain resistance is nothing but the change in drain to source voltage to the corresponding change in drain current for constant gate to source voltage. And the amplification factor mu is dependent as the change in drain voltage to the change in gate voltage at the constant drain current. So this is the relation mu, how we are relating the mu equal to GM into VDS here. Sorry, GM into RD here. And next one is in an N-channel FET, the effective channel length width is given, and the donor impurity concentration is also given. Find the pinch of voltage. So by utilizing this formula, we can able to solve this problem. So this particular problem we have already discussed in the problems on FET amplifiers. And next problem is a common source FET amplifier circuit with unbypassed source resistance RS. The given the different parameters of the common source amplifier here, and from this we need to find the voltage gain and the output resistance here. So here I'm providing the different formulas required for the common source amplifier. So from this we can calculate the voltage gain as well as output impedance of the given common source amplifier. So this one we have already discussed in the problems on common source session. And next one is a self-biased P-channel MOSFET has a pinch of voltage is given, Vp is given, and the drain saturation current IDSS is also given, and the supply voltage VDD is 12 volts given, and determine the value of drain resistance as well as source resistance. Also given the drain current is 5 milliamps and the VDS voltage is 6 volts. So first of all, we have to take the P-channel MOSFET and we have to derive the expressions from the drain and source resistances. So this problem also we discussed in the problems on common source amplifier session. And next, explain the construction and the principle of operation of depletion type N-channel MOSFET. So this is the depletion type N-channel MOSFET. In the N-channel MOSFET, we are having the P-type of substrate, and in that P-type of substrate, we are inserting two N-type of semiconductor materials. So channel is also in N form. So here we need to explain the construction, how we are constructing the P-channel MOSFET, how we are taking the semiconductor materials and how we are inserting, and how the gate is, how the gate voltage is varying the drain current we are going to discuss here. Next, compare depletion Mosfet and enhancement Mosfet. Also derive the expression for transconductance in field effect transistor. So here we are having two types of MOSFETs, that is depletion MOSFET and enhancement type MOSFET. So we are taking depletion type here and enhancement type here. We are taking different parameters for the comparison here. These are the symbols for the depletion type MOSFETs and these are the symbols for the enhancement type MOSFET. And the channel will exist permanently in the case of depletion type, but in the case of enhancement type, whenever we are providing the gate to source voltage as well as drain to source voltage for the MOSFET, then only there is a flow of charge carriers in the circuit. So that flow of charge carriers indicates the channel. And it can be operated in the depletion mode as well as in the enhancement mode, but this can be operated in only enhancement mode. So current flow, drain current flow whenever the drain to source voltage is applied, at that time VGS voltage is 0. Here in the case of enhancement type, there is no practical current flows on the application of drain to source voltage at VGS equal to 0. Current only flows whenever the VGS voltage is greater than the threshold voltage in the case of enhancement MOSFETs. These are the different comparisons between the depletion type and enhancement type MOSFETs. And to derive the expression for the transconductance, we are taking the transconductance, that is the ratio of change in drain current to the change in gate to source voltage whenever the drain to source voltage is 0. So this is the final expression for the G. After simplification, we will get this. And next one is a common source MOSFET amplifier, and they're given different parameters. And from these given parameters, we have to draw the circuit diagram. Okay, and we need to find a common source MOSFET amplifier is to be constructed using N-channel MOSFET, which has a conduction parameter of this much, and the threshold voltage VT is given as 0.2 volts, and the supply voltage is plus 15 volts, and the load resistance value is 470 ohms. Calculate the values of the resistors required for the biasing, that is nothing but R1 and R2 values. So for this given circuit, we have to draw the circuit diagram first. And next we have to calculate R1 value as well as R2 value. So this one is we already discussed in the problems on common source amplifier session. And next, for the circuit shown in figure, determine the input impedance and the output impedance as well as voltage gain. Voltage gain is equal to how much? So this is also a common source amplifier. We are having already direct formulas. If you substitute the values in that formulas, we will get the asked parameters here. So this problem also we already discussed in the problems on common source amplifier session. And next, explain the construction principle of operation of depletion type P-channel MOSFET. So once the channel is P-channel, means the substrate we are going to take it as a P type of material here. Okay, so this is the construction of the depletion type P-channel MOSFET, and this is the equivalent circuit. And how it is operating here when we are varying the different gate to source voltage, how the current is varying in the circuit, we need to explain here. And these are the different characteristics of the depletion type MOSFET. So these things we have to explain in this particular question. And next, explain the construction and principle of operation of enhancement type P-channel MOSFET. So here, see, this one is also similar to the previous question. They asked the N-channel MOSFET, but here it is the P-channel MOSFET, and it is in the enhancement mode instead of depletion mode. The basic difference is there is no physical channel exist in the case of enhancement MOSFET. Okay, so that's why we are not showing any channel here. Okay, we are taking one substrate and we are inserting two semiconductor materials, and after that we are placing the silicon dioxide layer and metal layer to grow the gate, and after that we kept all the terminals. And then we have to explain the operation of this one, by varying the different gate to source voltage as well as drain to source voltage. If you vary the two voltages, there is a variation in the movement of charge carriers and there is a variation in the channel length here. So these points in detail we need to explain in this particular question. So these are the characteristics of the given Mosfet circuit. And second one is long answer questions. So in that, explain the construction operation of a P-channel Mosfet in the enhancement mode as well as in the depletion modes with the help of static drain characteristics and transfer characteristics. So here we need to explain both the types of MOSFETs here, the construction of enhancement P-channel MOSFET and the depletion P-channel MOSFET, and also the operation of both the MOSFETs and also the transfer and drain characteristics of both the MOSFETs here. So here working of the P-channel MOSFET, how it is, how the current is varying in the P-channel MOSFET whenever the VGS voltage and VDS voltage is varying here. And next, similarly, the P-channel depletion MOSFET, how it is working and how it is forming here. And these are the characteristics of the enhancement MOSFET. So these are the drain characteristics and these are the transfer characteristics. So these are the characteristics in the depletion mode MOSFET. So in this way we have to explain all the points in detail in the case of a given question. And next, outline the drain characteristics of MOSFET for different values of VGS. Marks the different region of operation here. Generally, MOSFET will operate in three regions. One is the ohmic region, one is the saturation region, one is the cutoff region. So here we need to draw the transfer and drain characteristics of the MOSFET, and also we need to explain if you vary the different gate to source voltage while maintaining the gate to source voltage constant and by varying the drain to source voltage, how the drain current is varying and how the curves are shifting from one region to another region, we need to explain clearly here. And this indicates the transfer characteristics of the MOSFET here. So this is the explanation we got related to that graph. And next one is demonstrate the principle of common source amplifier with the help of circuit diagram. Derive the expression for voltage gain, input impedance and output impedance. So in this particular question, we need to explain about the common source amplifier first, and we need to derive the expressions for the voltage gain, input impedance as well as output impedance. So for that purpose, we need to explain the common source amplifier and we need to draw the circuit of common source amplifier, and these are the value of voltage gain we are getting in the case of common source amplifier. From the small signal model, we need to derive that value, and how much input impedance and output impedance we are getting, we need to indicate here. So the thing is, we need to draw the common source amplifier and explain its operation, and we need to take the small signal model of that one in order to derive the asked parameters, that is voltage gain, input impedance and the output impedance. And we're coming to the next question. Interpret the small signal model of common drain FET amplifier. Derive the expression for voltage gain and output resistance here. So here we need to consider the common drain amplifier with the supply voltage and load here. So in this case, if the Vn increases, the drain current is also increases. So the output voltage is also increases here. So that's why this is also called as source follower circuit. So the thing is, the output voltage is equal to the input voltage, but the thing is the level of the signal will be different here. So that's why it is also called as level shifter circuit. And next, to find the parameters, we have to go with the short circuit the DC voltage sources and open circuit the DC current sources. Then we have to analyze the circuit to find the gain parameter as well as input output resistances here. And next, find the expressions for voltage gain and output resistance. Draw the small signal model of common source FET amplifier. So again here we need to take the common source amplifier, how we are constructing that. and what is the working principle of common source amplifier, and after that how we are finding the voltage gain from the small signal model of the common source amplifier, we need to derive it. And next we need to find the input and output impedances from the small signal model of the common source amplifier. So each and every analysis part and operation part we need to explain detail in this given question. And next, list any four merits of MOSFETs to show that they are more suitable than JFETs in integrated circuits. So generally, MOSFETs are providing high input impedance. In that, MOSFETs are providing very high input impedance compared to the JFET here, and they are having high drain resistance due to the lower resistance of the channel, and we can easily manufacture the MOSFETs compared to the JFET, and it provides the very high speed compared to the JFET. So these are the four different advantages of MOSFETs compared to the JFETs. And next, develop the expression for transconductance of MOSFET. So to find the transconductance of MOSFET, we need to take the equation of drain current. So this is the equation of the drain current. We are rearranging that so that we are getting that. And after that, here the VGS voltage is, we are taking here it as VGS minus VT. Okay, this much. So after neglecting the small quantities, we are getting the ID and ID value. This is the DC current and this is the AC current here. So in order to find the transconductance value, we are going to take this AC value. That is 1 by 2 into mu n COX W by L VGS minus VT into VGS. So that particular value we have considered here, and this value is mu COX WL. This total value is constant for a particular value of gate to source voltage. So once that value is constant, means ID value will get it as GM VGS. So where GM is nothing but the transconductance. So from this we will get ID by VGS value. Relate the enhancement and depletion mode of a MOSFET with the help of its characteristics and construction. So in this particular question, we have to give the circuits of depletion MOSFET, okay, and enhancement MOSFET. Give the circuits of both the MOSFETs. That is nothing but construction, as well as operation of both the type of MOSFETs and also the characteristics. So here each and every these points along with the relevant circuits and waveforms we need to explain in detail in this particular given question. And next, illustrate the pinch of voltage and transconductance in field effect transistor. So here in this case, in the case of MOSFET, the width of the channel is function of the gate to source voltage, how much we are providing, and as well as how much threshold voltage we are taking into consideration here. So here this pinch of voltage is defined as the gate to source voltage at which the drain to source current is 0 here. And particularly in the case of MOSFET, the change in drain current divided by the small change in the gate or source voltages with a constant drain or source voltages indicates the transconductance of the amplifier or MOSFET amplifier. So the value of the transconductance is 2ID by VO. Next, demonstrate the small signal model of common gate FET amplifier. Derive the expression for voltage gain and output resistance. So here we have to take the common gate FET amplifier here, and after taking that we need to apply the KCL for that amplifier circuit. Then we can calculate the VGS voltage as well as VBS voltage. From that we can calculate the gain value, input impedance as well as output impedance. So first of all we have to take the common gate amplifier and its small signal model. We need to explain about that, and then we need to derive all these parameters in this given question. With the need speeches, explain the construction, principle of operation, and characteristics of N-channel depletion type MOSFET here. So in this case also we have to take the N-channel depletion type MOSFET, how we are constructing that N-channel depletion type MOSFET, and what is the operation of that one, and how the channel is the charge carriers are varying in the case of channel when we are providing the different gate to source voltage as well as drain to source voltage, and we need to see the operation of that one. Then after that we have to provide the required characteristics for the common gate amplifier. Next, make use of channel length modulation in channel enhancement MOSFET to describe the current variation. Generally, in the case of MOSFET, we take any particular MOSFET, we are having one substrate and we are having two pieces of N type of semiconductor materials we are placing here. This is the drain source and this is the silicon dioxide layer and this is the gate terminal here. So in this case, whenever the VGS voltage is applied, there is a variation of the drain current. But in the channel length modulation, this channel length modulation will occur in the saturation region of the MOSFET here. In the saturation region, whenever if you increase the VDS voltage, okay, the drain current is also increases. Why it is increasing means once the VDS voltage is increasing means the number of charge carriers will be reduced. Those are moving towards the source terminal here. So the length and width of the channel is reducing here. So the resistance of the channel is depending upon the length and width of the channel. So once the length and width of the channel is decreasing means the resistance of the channel will decreases. So once the resistance of the channel is decreasing means the drain current will be increases. So this particular concept we need to explain clearly by using relevant diagrams. And next, outline the advantages, disadvantages and applications of common source MOSFET amplifiers. So this common source amplifier having high input impedance along with low output impedance. That is the basic advantage. And while coming to the disadvantage, the output resistance of this one is not sufficient to run for the other applications. So it will provide the limited high frequency response. And while coming to the applications, these can be used for amplification of sensor signals and used in low noise amplification of radio frequency signals and in the communications systems like TV and FM receivers and in the voltage control devices in the case of op-amps and the cascade amplifiers and RF amplifier circuits also we can utilize this. And next, illustrate the advantages, disadvantages and applications of common drain MOSFET amplifier. So here common drain amplifier also called a source follower circuit and it provides very high input impedance and low output impedance. And this one we can also call it as emitter follower circuit in the case of transistor. And this voltage gain is unity. So this circuit we can utilize as the buffer amplifier. For the buffer applications we can utilize this common drain or source follower circuit. So we need to explain all the advantages and disadvantages and applications in detail. With the next pages, explain the construction, principle of operation and characteristics of P-channel depletion type MOSFET. So about this question we already discussed in the previous slide. We need to give the construction, working and the characteristics of the P-channel depletion type MOSFET for this particular question. And next, interpret the advantages, disadvantages and applications of common gate MOSFET amplifiers. So generally common gate amplifiers are utilized for the buffer amplifier. Why? Because it is having small input resistance and high output resistance. Because of that reason we are utilizing for the buffering. And it provides a power gain for the signal amplifiers. Okay. And while coming to the disadvantages, it is having low input impedance while offering high output impedance here. That is the drawback of the common gate amplifier. So while coming to the applications, we can useful for the RF receivers as well as in the frequency limiting circuits. We can utilize for the impedance matching purpose also, we can utilize this particular common source amplifiers. Next, illustrate the construction and principle of operation and the characteristics of an P-channel enhancement type MOSFET with the need sketches. So in this case, we have to explain about the P-channel enhancement type MOSFET. First of all, we have to explain about the construction of the P-channel MOSFET. So for the construction of the P-channel MOSFET, we have to take the N type of substrate and we need to insert two P type of materials. And after that, we have to place the silicon dioxide layer, then metal layer. After that, we have to insert the terminals of the MOSFET. And then we need to explain the operation of that one in detail. So that is nothing but we are applying different voltages, gate to source voltage as well as drain to source voltage, and how the charge carriers are changing and how the channel length and width is changing. We are going to explain clearly. And each and every point of this one we need to explain clearly for the given question. And next, explain the different regions of operations of MOSFET with relevant diagrams. So here it is going to operate in the three regions. The first region is the ohmic region, and second region is the saturation region, and it is also operating in the cutoff region. So here we need to draw this particular characteristics and at different voltage levels, how it is changing from one region to another region, and how the voltage levels as well as current levels are changing in the MOSFET. We need to explain clearly or in detail here. This is the explanation related to that particular characteristics, how they are varying with the variation of VDS and VGS voltages. And next, relate the main constructional differences between a MOSFET and a BJT. What effect do they have on the current conduction mechanism of the MOSFET? So here we are going to explain about the BJT as well as MOSFET. So the basic thing here, it is the current controlled device, here it is the voltage control device, and the current conduction is due to both the majority as well as minority carriers in the BJT, and in this case only due to the majority carriers. So these points we need to explain in detail for the given question. And next, demonstrate the construction, principle of operation and characteristics of N-channel enhancement type MOSFET with the need switches. So here also how we are forming the N-channel enhancement MOSFET. That is nothing but we have to give the construction, and next the operation of that one, and also the characteristics of the N-channel MOSFET we have to draw, and we need to explain the each and every region of operation from the characteristics of the N-channel MOSFET. And the next part of questions are short answer questions. So here illustrate the drain characteristics of the depletion type MOSFET here. So here we need to draw the drain characteristics of the depletion MOSFET and how the characteristics are varying by varying the VDS as well as VGS voltage, and what are the different regions of operation we need to indicate here. And next, interpret why MOSFET called as insulated gate field effect transistor. So here metal oxide semiconductor field effect transistor is also known as insulated gate field effect transistor. Why? Because we are using silicon dioxide layer as the insulator between the channel and the gate in the case of a MOSFET. Because of that reason, we are calling it as the insulated gate field effect transistor. Give the differences between the BJT and FET. About this question we already discussed in the part B. What are the major differences between the bipolar junction transistor as well as field effect transistor? We have to explain here at least some 4 to 5 comparisons we need to give here. Why? Because it is the short answer. And next, list the regions of operations of a MOSFET. So MOSFET will operate in 3 regions. One is the cutoff region, ohmic region and saturation region. So when it is operating in the cutoff region means whenever we are not providing any kind of voltages for the circuit, there is no movement of current, there is no movement of charge carriers in the device, so there is no flow of current in the device. So if it is in the cutoff region, MOSFET acts like a open switch. And in the ohmic region or linear region, in this case, the drain current, IDS current, is increases with increasing the value of drain to source voltage. So in this particular region, we can utilize the MOSFET for the amplification. And the next region is saturation region. In this case, we can get the constant drain current whenever if we increase the VDS. Okay, whenever this VDS voltage exceeds the pinch of voltage, under this condition, the diode acts like a closed switch. And the saturated value of drain current will be flowing in the circuit here. So in this case, we can utilize for the switching operation. In the cutoff region and the saturation region, it acts like a open and closed switches respectively. And in the ohmic region, it acts like an amplifier. And next, outline the IV characteristics of MOSFET. So in the IV characteristics, we are having the drain characteristics as well as transfer characteristics here. So drain characteristics are between the drain to source voltage as well as the drain current, while maintaining the gate to source voltage is constant. And the transfer characteristics we will take between VGS and IDS here. And after drawing this, we need to indicate all the regions of the operation along with the variations in the different voltages and currents. Show the circuit symbol of N-channel MOSFET. So N-channel MOSFET, in the case of depletion type N-channel MOSFET, the symbol is like this. In the enhancement type, the symbol is like this. Why? Because in the depletion MOSFETs, the physical channel is exist between the drain and source terminals. But in the enhancement type, there is no physical channel exist between the drain and source. So that's why we are giving the gap between the drain, source and substrate. And next, interpret the drain characteristics of N-channel enhancement type MOSFET. So this is the drain characteristics of the N-channel enhancement MOSFET, that is the VDS versus ID value by maintaining the VGS values as constant here. So here also it will operate in three regions, that is cutoff region, saturation region and ohmic region. So we need to explain some few points related to that regions, as it is the short answer question. And next, show the circuit symbol of P-channel MOSFET. So this is the P-channel MOSFET symbol in the case of enhancement type. Why? Because there is a gap between the drain and source. If you want to draw the depletion type MOSFET, the symbol is like this. This is drain, gate, substrate and source. So this is in the case of a depletion type P-channel MOSFET. And next, explain the terms drain resistance and transconductance. So drain resistance, it is the ratio of small change in drain to source voltage to the corresponding change in the drain current whenever VGS voltage is constant. So we can write RD equal to delta VDS by delta ID whenever VGS is constant. And transconductance, it is the ratio of change in drain current to the corresponding change in the gate to source voltage. That is GM equal to change in current to the change in gate to source voltage whenever VDS is constant. So these two formulas are very important in the case of FETs. Demonstrate how MOSFET acts as a switch. I have already mentioned once the MOSFET is operating in the cutoff region, it acts like a open switch. Once the MOSFET is operating in the saturation region, it acts like a closed switch here. Show the circuit diagram of common source amplifier. Common source amplifier means the source terminal acts like a common between the gate and drain terminals here. So here this indicates the drain resistance, this is source resistance, and this R1, R2 resistances are used to provide the required biasing for the amplifier, and this C1 is the coupling capacitor in order to couple the signal to the amplifier circuit, and this is the bypass capacitor in order to bypass the noise signal from the circuit. So this is the circuit diagram of the common source amplifier. Relate the significance of arrow and the symbol of MOSFET. See, always the arrowhead in the MOSFETs or BJTs indicates the direction of current flow here. Show the circuit diagram of common gate amplifier. So in the common gate amplifier, the gate terminal acts like a common terminal between the source and drain here. Okay, this is the source resistance and drain resistance. These two are the coupling capacitors in order to couple the input to the amplifier, and this C2 is in order to couple output to the load. And this is the supply voltage for the amplifier. Illustrate the concept of transconductance. So this transconductance is also called as mutual conductance. Okay, this will give the variation of the VGS voltage with respect to the drain current while maintaining the drain to source voltage in the case of a MOSFET. Explain the pinch off region. So the pinch off region or saturation region of the MOSFET indicates the it will operation of FET with more than few volts here. That is the pinch off region or pinch off voltage of the MOSFET. Extend the ohmic region of operation of MOSFET. So here ohmic or linear region is a region where the current IDS increases with increasing the value of drain to source voltage here. So when the MOSFETs are designed to operate in this region, they can be used for the amplification purpose. So we need to explain few points related how the MOSFET acts like an amplifier in this particular region. Show the small signal model of MOSFET. So here I am considering the MOSFET. So to draw the small signal model, we have to short or ground the all DC sources, that is VDD. We need to short, and we have to short all the coupling capacitors which are present in the circuit. And after that, we have to draw the small signal model of that one. And along with the load resistor, this one is the same. Illustrate why the N-channel MOSFET is considered better than the P-channel MOSFET. See, in the case of N-channel MOSFET, the mobility of electrons or carriers are more in the N-channel device compared to the P-channel device. And the speed is also more here. So because of that reasons, we'll prefer N-channel MOSFETs over the P-channel MOSFETs. Show the circuit diagram of common drain amplifier. So this is the circuit for the common drain amplifier. Name the types of MOSFETs. So generally MOSFETs are available in two classes, that is the depletion mode as well as enhancement mode. In both the depletion mode as well as in the enhancement mode, we are having P-channel and N-channel MOSFETs. So in this session now we have discussed the different questions related to the MOSFET circuits. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.